Hey guys, welcome again to the Maths Club. We are still on the series of set theory, and today we'll be looking at Venn diagrams and how we can shade Venn diagrams. For this particular video, we're restricting to a 2-set Venn diagram, and in subsequent videos we'll be looking at the 3-set Venn diagram. But before we begin, there's something very important I would like to discuss. So if you head over to our YouTube channel, I always say that the best way to actually get the best out of every topic that we do is by going to the playlist and starting from the beginning. So if you come to the YouTube channel, you see this home page, you see at this top here, you see something called playlists. So if you're starting with sequence and series, right, so if you can come here and view the full playlist, so you can see where we start from, and then you can follow through all the videos up till the very end. The WAEC past question that we treat at the end is just a sum of all the things that we've been doing just to bring it home. Same thing too if you were interested in any of all these topics, and then the way we take the topic, we are following the WAEC syllabus. The first topic on the WAEC syllabus is number base, so we are following number base, then this, then this, then this. We are not skipping anything. So once again, the best way to enjoy the best out of this channel is by following the framework that has been designed. So back to our Venn diagram shading. The first Venn diagram that we're going to shade is called universal set. So imagine that this rectangle is like the border of every possible element of our sets. So if we have subsets and all of those subsets, maybe subsets A, subsets B, which are all elements of this universal set. So this universal is like a rectangle, right? Because there are a lot of values that can be inside the universal set, but we're restricting it to this boundary. So if we wanted to shade the universal set, that means that I could say that it is denoted by U, right? And then if I wanted to shade it, you can see I can shade the entire place and say if I'm talking about universal set, everything within this boundary relates to that particular set. Now, where we have one subset, so in this case here, so A is just one subset of the universal set. So whenever I see this rectangle, just know that is the universal set. So if A is a subset of the universal set, it means that the values of A will be contained within this universal set. That is why we are having this depiction like this. So if I want to find out the elements of A, or the portion from this universal set that relates to A, and I want to shade that portion, what will I do? Can you see? I can just shade this portion and say out of all this universal set, the only part that belongs to A is this shaded portion. Now let's say an example. So we say have our A, and then we still have our universal sets. And remember, set A is a subset of the universal set. If any of these terminologies is looking strange, please check the previous videos to this particular video. Now, if I wanted to find the complement of A is every other thing apart from A. So if this is the complement, if this is A that is shaded, what do you think should be the complement of A? Great. So that means every other thing that apart from A in the universal set is our A complement. And we're talking about A complements in one of the previous videos. Now, if you have two subsets, right? We have two subsets, and this shows that A is a subset of B. Whenever you see this kind of symbol, you read it as A is a subset of B. If A is a subset of B, the reason why you're not seeing the rectangle or the rectangle here is because we're not dealing with universal sets. We're not dealing with one of the elements. We're just dealing with an element. If it's a universal set, we'll have seen the rectangle around. But B is a set, right? And we're saying A is a subset of B. That means that A is contained within B, within this bigger B, right? Now, if I wanted to shade the complement of A, that means that what is inside B that is not inside A. What do you think that shading will be? Great. Let's see if you're correct. Great. So you can see, so everything apart from what is inside A, but it's inside B, would be the A complement. Now we still have the same thing. If I wanted to find A intersection B, right? So like I said in that previous video, intersection is where both sets, where they intersect. So look at this diagram. What do they intersect? Great. Since A is a subset of B, that means that A intersection B will really just be the set A. Because both of them, I can find everything in set A in set B. So if I wanted to shade it, you can see that I can find everything in set A in set B. So A intersection B, if I shade it, will be really just shading set A. Now we have this third example. If I wanted to find A union B, look at, so A union B is like joining both sets A and sets B without repetition, right? If I wanted to shade the union of both of them, what do you think that would be logically? Great, so that would be set B. Really, it's just as if I'm just shading the whole of set B, because A is a subset of B, and if I want to join A and B together, it means that if I was just in that means I'll be repeating, there will be repetition, right? Because union does not have repetition. So if I look at that, you can see that by the time I shade A union B, it will just be everything. If any of these things are looking strange, you can always rewind the video and check it out multiple times. Now we have independent sets. Independent sets, so we have this sets A and sets B. There are two independent sets. There is no relation. I mean, before in that previous one, set A was inside set B, but in this case there are two independent sets. We have set A, we have set B. Then you can see this region here where they join. That means that there might be some point of intersection between these two guys, right? So let's see. If I want to shade A intersection B, right? So this is set A, this is set B. Where do two of them intersect? Great. So you can see that it will be inside this place here. Let's see if we're correct. Great. So you can see, right, the intersection is just where set A and set B they meet. Now, if I wanted to say A union B, that means I want to get everything in A and B, but without repetition, and I want to shade that A union B. That means basically I want to shade everything in A, and I want to shade everything in B. Let's look at what will happen. Great. So you can see it's just basically just shading everything, but without repetition. You agree with me that A and B, they contain some things that are common to each other, right? Because of the point of intersection. The point of intersection is what is in A that is also in B. So if I was listing out what is in A and what is in B, there will be some intersection, which we had here, right? So, but for the union, we are not going to repeat those intersections, because the union is the listing of all the elements in both sets without repetition. Now, look at this now. So we have A intersection B prime. We want to shade A intersection B prime. What do you think we should logically do first? So the first thing that we can logically do is, we know that A intersection B is this place here from that previous video, is this place here. So if I want to find the prime, that means every other thing apart from where they intersect. So that would be every other thing apart from this middle where two of them meet. Let's see if we're correct. Great. So you can see every other thing apart from this middle, that will give you the prime of A intersection B. Now let's look at this. So A union B prime. What do you think A union B prime would be based on what we have done? Great, right? So every other thing apart from everything in A union B. If I remove A union B, every other thing should be shaded. And you can see that, because A union B is this white patch. So the prime of it will be every other thing apart from the white patch. Still under independent sets, we have set A and we have set B. We want to find the complement of A. I want to shade that complement of A. Now, if we're shading a complement of A, that means everything apart from what is in A. So you can see A is this guy here, right? So A prime will be everything apart from this A guy. Can you picture out what the shading will be like? Great. Can you see that? So everything apart from A will be A prime. Now we want to find A prime or A complement intersection B. So I have the A complements now. This A complement, which is all the things that are shaded, right? Where does it intersect with B? So we have A prime. We want to find A prime intersection B. Where does it intersect with B? We can see that the boundary of B is just this guy here. It's just this other circle here. So if I want to find what all this outside plus what's this inside of this B would be, where they meet, it will just basically be this part here. What do you think? Let's see it together. Great. So you can just see that we have A complement, right? Where it intersects with B is just this portion of B that is shaded. I want you to actually take out a pen and be shading this thing. I mean, just intuitively, based on what we are doing, Try and shade it and see if you can actually get it. Well done to you. Now we have our set A and our set B, which are independent sets. If I want to shade B complement, what do you think that will be? Great, that will be everything apart from B. So only this B would remain unshaded. Every other thing would be shaded. Let's see if that will be correct. Great. So you can see every other thing is shaded apart from B. Now, just like the same thing, if you want to find A intersection B complement, so you already know what B complement is. Where does B complement intersect A, or where does set A intersect this B complement? So if you were to guess where this would be, where do you think that would be? We have set A, right? Imagine we have set A separately, and then we have this B complement, and we're saying where do they intersect? Of course, it should just be this part of A that is shaded. Great. So that's basically it about Venn diagram shading. I tried to make it as illustrative as possible with the effects and everything, but then try to watch it as many times as possible till you get it. If you have any question, any comments, please put it down in the comment section. I'll respond to every comment that I see. See you guys in the next video.